Okay, today we are going to learn about a specific type of reaction that is called redox reaction. So before teaching anything, I always try to tell the significance of that, okay, physical significance. The purpose of learning redox reaction is that it is going to mainly used in electrochemistry. In electrochemistry, you see the flow of electrons from one electrode to another, and it is basically the movement of electrons. So, how these electrons are generated from one species and who goes under lose loss of electron and who gains this electron, this all comes in redox reaction. So, when you understand redox reaction clearly, it will be easier for you to understand electrochemistry later on. Okay. So, redox is made of two words, red and ox. So, red means reduction and ox means oxidation. Earlier, they tried to describe reduction and oxidation in terms of oxygen. So, what they said for reduction, they said loss of oxygen atom. Okay, so if any reaction, if there is a loss of oxygen atom, that is a reduction reaction. That is true, but not all reaction involves oxygen atom. So, how will you decide reduction or oxidation there? Okay, so the another statement that came up was gain of electrons. So let's try to understand it with an example. So let's take magnesium dipositive, which is in a solution. So you write aqueous. It takes two electrons and it forms magnesium zero solid. So this two positive and zero are its oxidation states. So you can clearly see that it is going from +2 oxidation state to 0. So positive charge is reducing means electrons are incoming. So when electrons are received in the species, reduction happens. Okay. Similarly, for oxidation, first they believe that it is gain of oxygen atoms. Like if we write a simple example like ethanol going to ethanoic acid. So here you see one oxygen atom is now going to two oxygen atoms. So it is oxidation. This is oxidation because you are increasing oxygen. But not everywhere you will see oxygen atoms involvement. So how will you decide oxidation there? So similar like reduction, oxidation is loss of electron. It could be one electron or it could be many electrons. Okay. Example. Now if we reverse this reaction, magnesium solid going to magnesium 2 positive aqueous plus 2 electron. So now you see from 0 oxidation state to it is going to +2 means it is increasing positive charge. How any species can increase positive charge? When they lose electrons, right? So in oxidation, there's always a loss of electron happen. And these are the electron that flows through the circuit and it goes to the reduction channel where reduction of these species happens. So it's not like electrons are coming from somewhere else. In oxidation reaction, electrons are generated and those electron goes to the reduction place and their reduction happens. Okay. Now the another thing to learn in this oxidizing versus reducing agent. But before that, let's see an example of a redox reaction, a complete reaction in which redox process is happening. Okay. So suppose you have aluminum solid uh, and you have iron dipositive aqueous, and this is going to aluminum 3 positive in aqueous and you forming iron solid. So here if you see clearly, aluminum is in zero oxidation state and it is going to +3. That means increase in oxidation state. Increase in oxidation state means loss of electron. Means here oxidation is happening. In another scenario, you see iron dipositive is going to iron 0. So positive charge is reducing, oxidation state is reducing. That means reduction is happening. Okay. Now the another thing to learn in this is oxidizing agent, oxidizing and reducing agent. Okay. So what is this oxidizing and reducing agent? Oxidizing agent, let's start with. These are the agents that helps in oxidation. It helps in oxidation of other species but itself reduce. Okay, but itself reduce. For example, if we see the reaction above, uh, aluminum is oxidation is happening, but iron is reduction is happening. So iron 2 positive here is the reducing oxidizing agent because it is itself reducing, but it is helping in the oxidation of aluminum. Okay. Similarly, reducing agent, these agents help in the reduction of other species but itself oxidizes. Okay, reduction of other species but itself oxidizes. Okay, so if we see the example above, who is the reducing agent? Aluminum, because aluminum is itself oxidizing, going from 0 to plus 3, but it is helping in the reduction of iron because iron is going from plus 2 to 0. Okay, so yeah, it get confusing. Reducing agent means it helps in reduction of other but itself oxidizes. Okay, now let's do an example and try to find who is going under oxidation, who is going under reduction, who is oxidizing agent, who is reducing agent. Okay, so suppose we have copper dipositive aqueous and we have aluminum solid, and we copper dipositive is going to copper solid and aluminum solid is going to aluminum 3 positive aqueous. Before finding anything who is oxidizing, who is reducing and everything, first of all see whether the reaction is balanced or not. Not only the number of elements but also the charge. So I can see that the number of elements are balanced but charge is not balanced. In the right side it is plus 3, left side is plus 2. So what I'm gonna do, I'm gonna put 3 here, I'm gonna put 2 here. So now 3 times 2 plus 6, 2 times 3 plus 6. Now my elements are unbalanced, so I'm gonna put 2 here to balance aluminum, and I'm gonna put 3 here to balance copper. Okay. After this, we're gonna decide who's going under oxidation, who's going under reduction. So copper 2 positive is going to copper 0. So here our oxidation state is reducing, right? It is going from plus 2 to 0. So reduction in oxidation state means simply reduction. Okay. So from the statement itself, you can see the reduction word from where it came, right? And here aluminum solid from 0 oxidation state going to plus 3. So here increase in oxidation state means it is gaining positive charge. How something can gain positive charge? By losing electrons. So here oxidation is happening because loss of electrons is happening. So now we found out who is going under reduction. Copper is going under reduction, aluminum is going under oxidation. So aluminum solid is your reducing agent because it is itself oxidizing, right? And your copper dipositive aqueous is oxidizing agent because it is itself reducing but it is helping in the oxidation of element. Okay, So for this class, we're going to stop here, and this is going to help you later in electrochemistry to understand the electrons from where it is coming and how it is flowing from one electrode to another. Thank you.